Now let's review this figure 21-15. And before we do, I would like to take time to read something from NFPA 497, sections 4.2 and 4.3. And it basically states that the following three basic conditions shall be satisfied for a fire or explosion to even occur. Number one, it states a flammable liquid, vapor, or combustible shall be present in sufficient quantity mixed with air so that an explosion could occur. In other words, you're above the lower flammable limits and the vapor's on its way to being too rich in the upper flammable limits, which you find in figure 21-13 where it's illustrated. Now, the flammable liquid, vapor, or combustible dust shall be mixed with air or oxygen in the proportions required to mix properly with air so that an explosion could occur. And then three, a source of energy should be applied to the explosive mixture once it has developed. Now, those are three things that NFPA 497 in our sections 4.2 and 4.3 explains how we would attack an area to see if it's class 1, division 1, class 1, division 2, class 2, division 1, etc. So keeping that in mind, then, the next thing that's important is to go over to table 110.28 in the NEC on page 53. And there we find enclosures, outdoors and indoors. And it lists those enclosures. Now, we have dust enclosures, listed there. We have drip proof, rain proof, the different types of enclosures. The general purpose type enclosure for inside only, which is your type 1. Those are listed. But you do not have hazardous gas and vapor type enclosures listed at all. Now, those types are found in NFPA, or excuse me, that's wrong, NEMA. NEMA 250 is where you'd find those. And it's type 7, 8, 9, and 10. And of course, an explosion-proof enclosure that you see in this illustration, 21-15, notice that this enclosure will contain an explosion, but the hot gases escape through the escape path or the flame path, which is a width, a height, and a length. And as the gases passes through that escape path, it cools so it's below the ignition temperature of the gas or vapor outside the enclosure that could be present, or it's threaded. They'll have threads, and you have to have 5 engaged, and the gases will cool as it circulates through those threaded joints. Now we find in 500.8E, I believe it is, we find that you have to have 5 full threads engaged in the conduit entering that enclosure. The seals, all that has to be made up good and tight with those 5 threads, or that piece of equipment is no longer considered an explosion-proof piece of equipment. Now notice at the very top of the illustration we have the lighting fixtures, and luminaires do produce heat when they're operating. Engaged. That can cause an explosion mixture to explode if not selected based upon the ignition temperature of the gas or vapor. And as we said before, 501.30 deals with these luminaires, 501.130. If you're a Class 1 Division 2 fixture, it is the outer lamp that you have to make sure doesn't heat beyond the ignition temperature of the gas or vapor, the 80% rule. if it's a say a explosion-proof type fixture in Class 1 Division 1, then naturally it's the metal that can exceed the ignition temperature of the gas or the vapor. And then when you drop down to cord and plug connected equipment, then we have to review 501.140, 501.145, and then again there's usually two types of receptacle outlets that we naturally would look at. And it would be the kind that you cord and plug connect, and once it's cord and plug connected and energized, you can't energize it without turning it off. Then you have the type with a tube, the enclosed chamber, that contains the arc and distinguishes it, and therefore that type of receptacle could be used. But again, cord and plug connected and receptacle should be reviewed in 501.140 and 501.145. Then you have the switches, and any type of switch. We know we find that in 501.115, and it lists those types of devices and switches that can create an arc when they're switched. Arcing or sparking in any way have to be contained within an explosion-proof enclosure. Now, we know from our experience as designers and electricians that, we try to design with an enclosure that is rated for Class 1 Division 1, if that be the case. And there's, it's explosion-proof enclosures, purged and pressurized type enclosures, and intrinsically safe in accordance with Article 504. And that's Class 1 Division 1 areas, when our equipment can be put in those areas. Now, when we get into Class 1 Division 2, then there is a number of type enclosures that could be used based upon how the contacts that could arc or spark are enclosed. We'll see about that coming up. But let's look at the motor in the illustration. If it's a Class 1 Division 1 motor, it's explosion proof, or it's purged and pressurized. You're going to have to sweep it with 10 volumes of air and then pressurize it. Explosion proof type motor could be used also. If you're in a Class 1 Division 2, then it could be a totally enclosed fan cool motor with no arcing, sparking, or slip rings or anything like that you see in the illustration. It reads, motors with brushes, slip rings, or protectors cause arcs and sparks should be contained in some way. Or you could have a totally enclosed motor without those being present. So that's what this illustration is kind of getting over to the designer and user of the NEC, that sources of ignition must be contained as outlined in NFPA 497 4.3 and 3.3.2. To deal with hazardous locations, you just have to have the NEC, NFPA 497, NFPA 499, NFPA 496, and when you deal with ventilation, NFPA 30. So those are some standards that we should have on hand if we deal with hazardous locations. And this illustration is just pointing out that the equipment must be selected so that sources of ignition are totally enclosed in such a manner that they're not a threat with their arc or spark to cause an explosion in a hazardous classified area.